everybody, welcome back to CoronaChat. It's Caitlin. Today is Thursday, June 18th, and this is our new CoronaChat format, a once-weekly video that we release on Thursday evenings that provide highlights from the week in coronavirus developments. So this week we're going to kind of jump in. We've got a couple of different things that we want to talk about, and we'll see how this new format goes. So first up is the study from Cell that we started reviewing last week, right? This is one of the top premier peer-reviewed publications for cellular biology. So actually looking at the mechanisms of how cells and viruses and bacteria and things like that work, right? So this study is important because it provides us insight into how SARS-CoV-2, the virus that causes COVID-19, actually infects us. And the team that did this study is based at UNC Chapel Hill, which, full disclosure, this is also where I work and study. But this team works with the actual virus to understand something called its mechanism of action. Basically, how the virus gets into a cell and then uses that cell to create more viruses and then go on to infect other cells. Right? Notably, this is a team of experts in coronaviruses. Right? They've been studying coronaviruses for years. They also work on the viruses that cause SARS, that cause MERS. This is not a team that suddenly pivoted and started to work on coronaviruses. They've got really deep expertise in this area. Now, there's a lot of stuff in this paper, but the kind of two big things for us are as follows. So the first is that it seems like the virus infects us first through the cells in the inside of our noses. When we breathe in air that has virus particles, right, these particles set up shop in the cells in the inside of our nasal cavity. And once the virus effectively colonizes the nasal cavity, it moves on to other places, like the lungs. This means it's super important when you wear your mask to make sure that it comes up and it covers your nose too, right? And not just your mouth. I think I've definitely, as I've been kind of out and about doing my social distancing, going to the grocery store, right? I've seen some folks who've had their mask on over their mouth, but not over their nose. So it's really important that the mask covers both your mouth and nose. And before you think, well, wait a minute, I'll just breathe through my mouth and not through my nose, and then the virus won't get me, right? And I don't have to wear a mask. The virus may be able to land in the wet tissues in your mouth and throat and then kind of migrate on up into the nose, right? So please just wear the mask. The second big thing in this study is that in doing this research, the team of investigators were able to develop lots of tools that will make future research onto this virus easier and more effective. And the more we understand about how the virus works, the better able we will be to develop prevention measures and treatments that stop it in its tracks, and maybe even come up with an effective vaccine. So this study was really important for what it gives to future research as well as for what it tells us right now. Okay, so the next big piece of news had to do with the recovery trial. This is a very large randomized clinical trial being run by researchers at the University of Oxford in the United Kingdom. And this trial is testing a number of different possible treatments, including some that you may have heard of, so combined lopinavir and ritonavir. These are two drugs used to treat HIV. Interferon, which is normally used to treat multiple sclerosis, hepatitis C, and some blood disorders. Dexamethasone, which is a corticosteroid used to reduce inflammation. Our friend hydroxychloroquine, right, usually used to treat lupus. Azithromycin, which is a very strong antibiotic, and convalescent plasma, right? So this is plasma kind of taken from a blood product derived from the blood of people who've had COVID-19 that have gotten better. There's a number of other drugs in this trial as well, but those are the ones that may sound familiar. So some of these potential treatments are also under study in the WHO's, the World Health Organization's Solidarity Trial, which is another reason they might sound familiar. So every drug on this list was included because there was some preliminary data to suggest that it might be effective. Either an earlier human study that was done but didn't use a rigorous study design, so it showed something that maybe looked positive, but we needed a good rigorous study design to figure out if this was a true effect. Or there was evidence that the drug does something that's important with respect to disrupting that virus's mechanism of action, right? It either prevents the virus from getting into cells, or it prevents the virus from replicating once it's in cells, right? Or maybe this drug does something to interrupt the way that the virus causes severe illness and death, right? So that's what we're looking for as we think about what drugs might be potential treatments or potential candidates for a clinical trial, right? It's not just like we're going to try every drug possible. We want to pick things that seem like they've got a high probability of success. So the researchers in the recovery trial announced this week via a press release that hydroxychloroquine had no effect, and that a few more people in the group receiving hydroxychloroquine died as opposed to those who did not receive an experimental treatment, although this difference was not statistically significant. And they also announced that dexamethasone seemed to have an effect. Now, none of those results have yet been written up or published either as a preprint or as a peer-reviewed manuscript. So there has been no major outside public review of this data yet. And of course, this means that we all need to take a collective deep breath and try to wait until we can see the data. Especially with all of the big headlines around these so-called miracle cures, right? That something goes out and then it gets pulled back and we think it works and it doesn't. We really need to be a little bit skeptical. So while this is potentially exciting, big news about dexamethasone, let's try to hold on a little bit longer without getting too excited so we don't have our hopes dashed if it turns out this isn't quite as miraculous as it seems. And I really, really hope that I am being overly cautious and cynical here and that next week I'll tune in and say, hey, we got the data and oh my gosh, it works, we have a miracle cure. But we're not there yet. So alongside the recovery trial, right, the World Health Organization has continued to manage the Solidarity trial, which is also testing many, many drugs, including hydroxychloroquine. And researchers at the Cochrane collaboration have also been conducting a systematic review of the literature on hydroxychloroquine. And what this means is that they track down and read every single relevant study about hydroxychloroquine and COVID-19, look at how rigorous they were, look at the methodology, what did they find, how believable are these results, right? But they read everything. And then they explain to all the rest of us what this entire body of literature says instead of just one study, right? Because when we look at everything in its entirety, we have a better understanding of what's going on than looking at just a single study. Now, based on the World Health Organization's own data from the Solidarity trial, right, the findings of this Cochrane review, and this new preliminary information that we're starting to get about the recovery trial, WHO has determined that there does not seem to be any benefit of hydroxychloroquine. And based on that determination, WHO has decided that the ethical thing to do is to not randomize any more people in their trial into getting hydroxychloroquine. Right? So as they are continuing to recruit patients into this study, people will be randomized to receive those other treatments, but nobody else is going to get hydroxychloroquine. And their reasoning for this is that there's no point in giving people an experimental treatment that we know doesn't do anything if there are other experimental treatments that might work. So patients, like I said, enrolled into the Solidarity trial, they'll get randomized into either usual care or one of the other drugs that are being tested. And anybody who is already receiving hydroxychloroquine will be allowed to either finish their dose or stop early, depending on what the patient and their physician thinks is best. But that is kind of the decision that was made with WHO in the Solidarity trial. Other hospitals, other countries are making their own decisions, but that is what WHO is doing for the trial that they have jurisdiction and responsibility over. So also this week, the Food and Drug Administration, the FDA, decided to withdraw the emergency authorization for hydroxychloroquine and chloroquine to be used as off-label as treatments for COVID-19. And again, their rationale was the overall body of evidence suggests that these drugs are not helpful and could actually be harmful. Again, the idea here is that we don't want to waste precious time or taxpayer dollars on experimental treatments that we can see don't work when there are other things that we could be trying. So I know there's been a lot of churn around hydroxychloroquine lately, but it seems like at least at this moment we're saying, based on everything that we're seeing, it doesn't seem like this drug is super helpful, so we'd rather focus our energy in other places. So I know that was a lot of information today, but I hope that this rundown was helpful. We'll be continuing to post kind of up-to-the-minute news updates of things that seem really important for you to know on our Facebook page and on our Instagram page. And then we will be back with another video next Thursday. In the meantime, remember we are all in this together. Stay safe, take care of one another, and we'll see you all back next week.